Okay, so in this video, we're going to go through some revision notes for EDEXCEL-Math, IGCSE, Topic 5, Square Numbers and Cube Numbers. So to begin with, square number. What is a square number? A square number is any perfect square. A square number is any perfect square. What do we mean by perfect square? It's a whole number product of two same numbers multiplied together. So a whole number product. The product must be a whole number of two same numbers multiplied together. Two same numbers, for example, 6 times 6 is equal to 36. So 36 is a whole number product of two same numbers, 6 and 6 multiplied together. So 36 is a square number. It's a perfect square of 6 squared. Okay? 36 is a perfect square of 6 squared. Square numbers can be represented by square root. Alright, for example, 36, root of 36 is 6, because 6 times 6 is equal to 36, or 6 squared. Cube number is the same thing as a square number, but with 3 digits. It's any perfect cube. This means any whole number product of 3 same numbers multiplied together. Sorry, yeah, 3 same numbers multiplied together, but like 3 times, but the numbers must be the same. So, for example, 5 times 5 times 5, the same number multiplied together 3 times will give 5 to the power of 3. The number up represents how many times you have multiplied this. If it was 5 times 5 times 5 times 5, it will be 5 to the power of 4, and so on. So 5 to the power of 3 is 125. So 125 is a cube number, or perfect cube of 5 cubed. Since a square root represents a square number, a cubic root represents a cube number. So cubic root is usually written as your square root with a 3. And cubic root of 125 is 5. Coming to surds. So surds is a square root of a non-square whole number or integer. So it's a square root, it is a square root, okay, a square root of a non-square number. So non-square whole number is like, for example, 36 is a square number because 36 is 6 times 6, right? But 7 is not a square number because there are no two same numbers that multiply together to give you 7. So root of 7 would be considered a surd. It's the square root of a non-square number. Okay? For example, root to the power of 2, root power of 5, root 13, 15, 3, 99, 10, and etc. Okay? 16 is not a surd because it's a square number. 16 is 4 times 4. How do you calculate or simplify surds? Here are the general rules. Square root of a times square root of b gives you square root all a times b. For example, 3 times 5 will give you root 3 times 5, which is root 15. Root of a times root of a is root of a squared, and root and squared cancel, so root of a times root of a is just a. Root of 15 times root of 15 is 15, or 15 to the power of 2. This cancels, you get 15. Root of a divided by root of b is complete root a over b. So for example, 21 divided by 7 is complete root 21 over 7, which is root 3. Remember, you must keep the root sign in your answer unless there is a square. Root of a over b, reverse the process from here. It's root of a divided by root of b. So just reverse this. 21 over 7 is 21 divided by 7. You get the same answer. Now, what if we have coefficients? C root of a times f root of b. You multiply the coefficient with the coefficient, and you multiply the root with the root. So this is going to be c times f and a times b. So cf times root ab. 3 times 5, 3 root 5 times 4 root 3 is equal to 3 times 4, which is 12, and 5 times 3, which is 15. 12 root 15. For division, you do the same thing. Multiply the coefficient, divide the coefficient by coefficient, divide the root by root. So 8 divided by 4 and 4 over 2. Simplify this, 8 over 4 is 2, and 4 over 2 is also 2, so 2 root 2. Now, for example, this is usually the most common case when we have a square factor and we need to simplify the square factor. So, for example, root 150. In root 50, 50 is 25 times 2. So root 25 times root 2. Root 2 cannot be simplified anymore, but root 25 can be simplified more to 5. So the answer is going to be 5 root 2. Root 48 can be simplified to root 16 times root 3. Root 3 is the simplest form, but root 16 is a perfect square of 4. So this is going to be 4 root 3, and so on. To add and subtract surds, it's very simple. If you have the same root base, you can add or subtract, but you keep the root the same in the answer. If you have a different root base, that means it is already in the simplest form. For example, 3 root 5 plus 7 root 5, here 3 plus 7 is 10, and keep the base the same in the answer. 3 root 7 and 5 root 2, the bases are not the same. This means that the surds are in simplest form. So that was one way to add them and subtract them. Another way is by simplification. So by simplification, if we have two surds that can be simplified by using common factors, we can also do that. For example, root 8 plus root 72. 8 is, now in the calculator, if you put root 8, you're just going to get root 2 root 2. But actually, it's root 4 times root 2, and root 4 is 2, and 2 remains the same. So that's how we get root 2 root 2. 72 is root 36, and root 2. Root 36 is a perfect square, it's 6, and 2 remains the same. Now that we have the same root base, we add the coefficients. 6 plus 2 is 8, 8 root 2. It's somewhat like the fractions, where you have to make the denominator the same to perform addition or subtraction. In this case, if simplification is possible, then you try to make the bases of the roots the same by simplifying into AB form. For subtraction, if you can just put it directly into the calculator, you're going to get root 45 is 3 root 5, root 32 is 4 root 2. This is already in simplest form because the roots bases are the same. Okay, and to end this chapter off, how do we multiply surds by distributive property? So again, distributive property is the same in every equation or in every bracket question. You just have to multiply what's outside by what's inside. You multiply the digit outside by everything inside step by step. So for example here, a times b and a times root c. 5 times 2, 10, 5 times root 3, 5 root 3, 10 plus 5 root 3. This is FOIL method. This is F, this is O, this is I, this is L. A times C, A times D. B times C, B times root D. Multiply them, you're going to get the answer. And if it's squared, just open up the brackets and then just use the FOIL or distributive property. Rationalizing the denominator. This is commonly used when we have surds in our denominator because you cannot have a surd in the denominator. You must get rid of it at all costs, and you cannot perform a calculation either on calculator or theoretically or on paper while having a surd in the denominator. So the first thing to do whenever you have a surd in the denominator is to rationalize this denominator. What do we mean by rationalization? Rationalization is changing a fraction with surds in the denominator into an equivalent fraction. But this means that the fraction that had the surd in the denominator is the same thing as the equivalent fraction. They're both the same fractions. The only thing is that we just remove the surd from the denominator. How do we do this? We multiply the top and bottom of our fraction with the surd of that denominator with the opposite sign. So let's take some examples here. For example, 1 over root 3 plus 1. This fraction is not accepted because root 3 is a surd. So to get rid of root 3, we multiply the fraction up and down with the denominator with the opposite sign. Here we have positive, so we're going to multiply by negative. So times root 3 minus 1, root 3 minus 1. 1 times root 3 minus 1 is root 3 minus 1. Root 3 times root 3, as we said, root a times root a is equal to root a squared. right? And root and square cancel each other out, so you're just left with a. So root 3 times root 3 is just 3 plus 1 minus 1 minus 1. So our answer is root 3 minus 1 over 3 minus 1. You can also simplify this further into root 3 minus 1 over 2. This way, this is just an equivalent fraction of our first fraction, but it's just that we remove this surge from the denominator. And that is it for this topic.